Okay, so I think we can get started. Uh, Good afternoon, everyone. My name is Tejas. I run the APAC business for CockroachDB. CockroachDB is a highly resilient and a scalable SQL database. Today, I'll be talking a little bit about how a lot of SaaS companies have scaled their businesses with help of a distributed architecture on top of CockroachDB, and how you can build a resilient SaaS ecosystem on top of CockroachDB, right? By the time they are going to change that picture, but that's definitely not me, right? So I'm going to get started with something which, okay, I don't think this is working. Okay, it works. There was a hot take. I don't know if any one of you got to see this hot take on Twitter that SaaS is dead. Anyone, did anyone see this? This was very recent by one of the VCs at First Mark Capital. He tweeted like a long tweet about how SaaS is dead. And then there were a bunch of counter tweets and a lot of things kind of came out of that, which is very interesting, right? We do acknowledge that there are headwinds around SaaS as a business, but definitely it is way far from being dead. And nothing else can prove that, because this image was actually created by another SaaS company, which is a $2 billion USD revenue company, just from a SaaS point of view. However, what's happening today is we are seeing an amazing confluence and convergence between SaaS and AI. So AI is going to fuel some of the use cases of SaaS, but definitely not dead for sure, right? So what's happening? SaaS is definitely rebooting for sure. I think we all can agree on that SaaS is rebooting because there are several major headwinds when it comes to SaaS companies today. How many founders in the room today? Okay. So you're going to really like the next one, because probably you can really resonate with this, right? There are three main, if you're a business owner and have a SaaS company or running a SaaS company, these are three main challenges that we see across the spectrum after speaking to several SaaS companies. The first one is you need to balance growth in a sustainable manner. You still need to keep growing, but you also need to focus now on profitability. If someone would have told you this in 2021, you would have probably shrugged off, right? So your VCs are expecting you to improve your runway, to improve your unit economics, to improve some of these metrics, but at the same time, you're not expected to slow down in the growth. If you are growing anywhere less than 25 to 30%, it's looked down upon. So how do you manage and balance some of these things that you grow sustainably? The second thing, it's the harsh truth. I think we should all accept it. The budgets are moving towards AI. Every time a company onboards a fancy AI tool like Glean or ChatGPT's enterprise licenses, it's coming at a cost of non-critical SaaS companies. The budgets are shifting, right? So there's, of course, a lot of overload and market saturation when it comes to AI, and that's another concern from the existing SaaS founders who are yet to integrate AI into their workloads. How do we manage that risk very efficiently? And the third and the most important one, you built a SaaS company so that you can sell it to the globe, right? You didn't build a SaaS company just to focus on US or just to focus on India. Your eventual goal, yeah, you can probably start from India and then expand into US or vice versa. But the reason why you built a SaaS company is because you want to sell it to the globe. So this is another concern that a lot of SaaS founders typically have is, how do I quickly activate a new region based on the newly available information that I have? How do I expand very, very quickly? How do I hire people in US, get started with US, and have my infrastructure up and running as and when I require to be there? On the flip side, it's also how do I scale back, right? I've started my India operations from a GTM point of view, they're not working. How do I also scale back? And all these three challenges are now having downstream effects on technology teams. So how many from the engineering teams out here, right? Core engineering, coding, DevOps, et cetera, right? These are the 5 key challenges that are now having the downstream effects of your business teams. The first one is your customers don't really care whether you are in a single AZ or a multi-AZ or DigitalOcean or AWS. What they want is an always-on experience, no matter what. Because let's be honest, they have their customer data also riding on it. So you have to ensure that no matter what, you are able to give a digital foundation that is always up and running. If you are in B2B SaaS selling to fintechs, you will come across very interesting use cases where customer says, hey, I don't care if you've built your SaaS on AWS, I still want to be able to deploy this on-premise, or I want it on Azure, or I want it on GCP. So how do you manage your SaaS ecosystem, which is cloud agnostic and could be potentially deployed on different platforms as and when you start scaling, or as and when you have certain large customers requesting some of these things? Third one, scaling and hiring in new regions is easy, but the challenges come with the data regulations and compliance. If you are having customers in Bay Area, California, you need to comply by California's Privacy Act. In India, we are soon going to have our own Digital Protection Privacy Act, which is DPDP, which is still in work in progress. And if you're selling into Europe, you have to comply by GDPR. So that's always on top of the mind, that how do I ensure that I'm minimizing my risk around regulatory requirements and around compliance requirements as well. The fourth one, how do I achieve global scale? How do I scale very fast? You could be a SaaS company who has started up with 1 or 5 customers, but when you scale to 200, 250, or 500 customers, the dynamics look completely different. So one question on top of your mind is always, how do I scale this part very quickly? And of course, the last one is, when a lot of SaaS companies started scaling in 2021, the architectures actually became messy. Why is that? Because you had a SQL database that was working perfectly well. Now you had tons and tons of customers coming on your platform. Companies were modernizing. You started putting...
Am I process data? No. Completely process data in single store. So in that case, it's going to be big cheap.
So in 2021, when companies started scaling, one of the challenges was, how do I start scaling? And because your SQL database could not scale, a lot of companies started putting layers of NoSQL. It was Mongo, Cassandra, Redis on top of it, right? But now companies really want to see and come back to the data consistency part and see how potentially they can provide an experience which is correct and consistent for certain use cases. And we'll cover some of them as we move forward. So this is what happened, right? Very likely, if your SaaS company started 5 to 10 years back, you potentially started on a monolithic database on PostgreSQL, one of the most popular open source databases, or MySQL, either one of them. Of course, if you are building financial services tools, it could have potentially been SQL Server or Oracle. And then you need an immense amount of scale. So what do you do when you need scale? You use a NoSQL database to improve that scale. So you start putting a layer of MongoDB or Cassandra on top of it so that you can start scaling. But with this comes challenges of data consistency at times where not all of your users are seeing the same state of data. And because of these issues, it tends to erode the trust. And in order to make this part scalable, you have seen cloud-augmented legacy databases. What this means is a lot of cloud providers took the open source ecosystem, the vibrant open source ecosystem like PostgreSQL and MySQL, and started providing them as service by building a layer on top of that. We might be familiar with AWS RDS or Aurora or Cloud SQL. And they do help you with scale to a certain extent, but they are all limited by a single writer use case. What this means is, as and when you have high transactional concurrency and you need high number of writes, these monolithic databases start to choke. That's when you need something which is cloud native, which is modern, which is built for modern applications, and which is also distributed. To put this in perspective, these are some of the customers that we have worked with at every level of their scale. We have seen customers who started on a single distributed database, on a single data center, let's say Mumbai region, in a multi-AZ fashion. Launched Darkly and Riskified started their platform with us in order to standardize their deployment. So they moved from PostgreSQL and monolithic databases like PostgreSQL and MySQL to something like CockroachDB, just on a single distributed SQL database. And then there are companies like Fortinet and Five9 who said, hey, we just don't have operations in one region, but we also operate in Australia, in US, in UK, and in India. Can we have a distributed set of databases across all these regions? And all they had to do is spin up some clusters as and when they started scaling. To top it up, there are also some of our customers, and the previous talk was more about identity access management. This is a very interesting use case because when it comes to identity access management, you are storing some of the most critical and private data of the users. And that's where you need to comply by the local laws and regulations. For example, GDPR laws and regulations where you can't take that critical PII data out of those regions. So there we have identity and access management companies like Ori Hydra, which is a very popular open source OAuth framework, and OAuth, who are using CockroachDB as a globally distributed data store across multiple regions, sometimes 5 regions, sometimes 7 regions as well. So it doesn't really matter in which journey are you or where you are actually starting from. CockroachDB helps you to go from initial cloud adoption to a global scale and a global reach, right? So what exactly is CockroachDB, right? It's like, okay, we understand the problem statement here. We really understand how we can potentially scale. In a nutshell, CockroachDB gives you the familiarity and the reliability of SQL databases that you are already familiar with. It is Postgres wire compatible. So when you speak to CockroachDB, it feels like you're speaking to PostgreSQL. But it scales like NoSQL, which means that you can scale horizontally. You are never going to be bound by how much of data do I need to put into it? How do I scale this thing? Do I scale vertically? Do I scale horizontally? Do I do manual sharding? Those questions will never be on top of your mind. You'll be more focused on building features. You'll be more focused on GTM without worrying about how do I scale this. At the same time, this is also cloud agnostic. So today you are probably running on AWS. Tomorrow you might want to run it on GCP or Azure or any other platform. This relieves you from that lock-in. It gives you the flexibility to run it potentially on any cloud as such, right? So there are mainly 3 challenges that we are here to solve for SaaS companies. One is help you scale very, very fast and also scale down sometimes, right? We all know that sometimes some regions work for us, some regions don't work for us, some markets work for us. How do I also scale down after some peak loads that I've had? So one is helping you to scale very, very fast. The other is to survive all sorts of failures. We see a lot of platform engineering teams trying to do manual sharding, trying to upgrade MySQL from 5.7 to 8, toiling hours and hours of time, right? These things are not easy to do without taking downtime, but there has to be a better way. How do we help you reduce your unplanned and planned downtime to almost 0? So that's the other thing. We help you survive all sorts of failures. And the third, as I said, you should be able to thrive everywhere. You should be able to run on any cloud, on any platform of your choice, right? Since there are a lot of technical folks here, we'll get slightly more technical and we'll go into, okay, this looks too good to be true, right? How can you say that you are also a SQL database, but you can scale like a NoSQL database? So let's get into some amount of high-level architecture deployments on how does it actually work on ground level. So first thing to know in CockroachDB is because it is distributed in nature, every node is a read-write node. What this means is you can connect to a load balancer and you can query any node, not only for just read or write operations, but both operations. Unlike monolithic databases where you have a master and a replica architecture, and the only way to scale that out horizontally is by adding more read replicas, right? Otherwise, it's too cumbersome to scale, or you have to sometimes do manual sharding as well. Because every node is a read-write node, it also allows you to survive all sorts of failures, right? Another important thing to note is the data is replicated 3 times. So if you have 1 GB of data, we will ensure that 1 GB of data is also residing on other 2 nodes. This gives you, again, an additional ability to do maintenance on one node, to upgrade it, to survive failures, right? The architecture is designed in a way that the latency between the nodes would never be a problem, and it's a clean installation. You have one single binary that gets installed, and you can get started very, very quickly. We've come across certain distributed databases which are grafted on top of open source databases like PostgreSQL or MySQL, but in those cases, you also have dependency on the downstream versions of PostgreSQL and MySQL. In CockroachDB, it was built ground up, so it has absolutely no dependencies on the downstream versions of these open source databases as well. And how do you scale with CockroachDB? When you have to scale your monolithic database, what you do is you do vertical scaling. You go from 4 vCPU to 8 vCPU to 16 to 32, and then at some point in time, if you have terabytes of data, very likely you're going to hit a vertical limit of scaling. And then you have to rework with your engineering team to do some sort of sharding or manual sharding or splitting your data into multiple nodes. There has to be a better way. The way you scale with CockroachDB is horizontally. So you start with a 3-node cluster. If you need more throughput and more data, all you need to do is just add another cluster, another node to the cluster. Through CockroachDB's gossip protocol, CockroachDB will realize there is another node which has joined the cluster, and it will move all your data around between the nodes. It's as easy as that. You don't need to take painful downtime in order to scale. And same happens with scaling down. When you want to scale down, you just repave the node, you get rid of the node, and all your remaining data will come to the other nodes. We have seen companies storing hundreds of terabytes of data with CockroachDB in a single cluster. We've also seen hundreds of nodes in a single cluster with CockroachDB. So it's highly, highly scalable if that's something that is on top of your mind, right? And it's also got built-in resilience. Because we, as I said earlier, we copy the data 3 times, CockroachDB can survive all sorts of failures. In a single multi-AZ deployment, CockroachDB can survive failures like node failures and AZ failures. I don't know if anyone has experienced an AZ failure, and unfortunately, if you had your master node in that AZ failure, the impact on the behavior, yeah, you're bound to lose some data. Yes, there is always going to be a promotion of the replica which will happen, but during that time, you definitely lose some amount of data, and it erodes a lot of trust, right? Key factors while designing large applications, people worry about what is going to be my RPO, recovery point objective, and recovery time objective. With CockroachDB, you can bring it as down as almost to 0, right? You can bring down your planned and unplanned outages to also almost to 0. This is really important, right? Everything that I said before this, a lot of NoSQL databases can give you. NoSQL databases were actually built to give you scale. So how do you manage consistency is probably something that you're thinking, right? That, hey, if I have the ability to write to any node, how do you ensure that I always get the right consistent data? So the answer is, at CockroachDB, we spent significant amount of time in architecting this. Under the hood, we use something called Raft protocol to ensure that you always get the consistent data. CockroachDB is ACID compliant. CockroachDB follows the CAP theorem aspects of it, and it is also following one of the highest consistency level, which is called serializable isolation. We also have a weaker isolation level, which is called read committed. But these days, a lot of people don't care actually about the isolation when it comes to databases. They just want to get started, right? So one thing to note is, with all this goodness, you are not actually compromising on the consistency of the database. You will always get the right consistent nature. And that's why we have a lot of stories where companies started off with Cassandra as their metadata store, but then they realized they were not getting the right consistency. They were seeing data challenges. They were seeing consistency challenges, which was eroding the trust. And they moved to something, again, which is SQL, but distributed, which is CockroachDB, right? So to summarize, when you speak to CockroachDB, these are the familiar frameworks that you can use. Continue to use your existing ORMs, your connectors. When you speak to CockroachDB, it will feel like that you're speaking to Postgres, but it scales like NoSQL. It scales horizontally out of the box. And you can read and write from any node. So there is no dependency on a single master writer, which typically gets choked when you have high number of transactions. That's what we've seen so far. At the same time, the data is always consistent. So if you have use cases where you do an immediate read after write, you will always get the most consistent data which is available in the system. It is also able to survive failures. As we shared earlier, it can survive node failures and AZ failures. If you need higher amount of failures, you can always add more nodes. So if you had 5 nodes, you could potentially survive 2 nodes going down, right? And thereby, you can also increase the resiliency of this. No downtime for rolling upgrades. Absolutely no downtime. And I think in today's world, a lot of platform engineering teams have taken downtime as a way of life, working on Saturdays as a day of life, working during odd hours as a way of life, right? There has to be a better way. With CockroachDB, you can completely eliminate your planned downtime to 0 because we support rolling upgrades out of the box, and also no schema changes. Every time you have to roll out a small feature, a lot of times you have to take the database offline to integrate those schema changes. With CockroachDB, you can do online schema changes, thereby further reducing your planned downtime. And the more downtime that you are able to reduce, you can differentiate yourself as a SaaS provider who's providing a much higher uptime. And you can keep asking for premium valuations because there is always, remember, there's always someone, when it comes to SaaS, to do things cheaper, better, and faster than you, right? This is how you differentiate from value, that the amount of downtime that you have is almost negligible, right? And the way to scale CockroachDB is you can go from 3-node cluster to 5-node cluster by a few clicks. The data will automatically get sharded. It will get moved away from one node to another. You don't have to do any manual intervention out there. You can also scale both vertically as well as horizontally. This is interesting, right? You started off with a US GTM. You've been successful there. You've been doing phenomenally well. Now you plan that you want to expand into India from a GTM standpoint, and then you also want to expand into UK in Europe, right? With CockroachDB, just by spinning up net new clusters in different regions and getting started, it's as easy as that, right? Whereas you don't really have to worry about how will you manage your compliance. The cluster in US is CCPA compliant. The cluster in India, whenever we implement this act, should be soon, would be DPDP compliant, and the cluster in Europe is GDPR compliant. This compliance comes out of the box. You don't have to create different RDS clusters or Cloud SQL clusters in different regions and have different states of data, because there are certain services, certain common services that you invariably end up replicating. Because it's not just the database, right? At the end of the day, this database needs to speak to so many things. This is one thing that we realized early on, that no point in building a shiny database that doesn't speak to anyone else, right? Because while CockroachDB is your source of truth, it's your transactional OLTP database, you're always going to do some analytics on top of it. You're going to push out some data through change data capture from CockroachDB. These are extremely rich ecosystem partners where we've built a lot of integrations with some of the existing partners so that you're not just relying on CockroachDB, but you can push out your data for OLAP analysis, et cetera. From a monitoring standpoint, we had someone from New Relic who was speaking, I think, a couple of slots before. So we integrate with New Relic, Datadog, Prometheus, and Grafana. These are like table stakes in today's databases. You need to be able to integrate with external sources as easy as possible, right? So now you must be thinking, okay, this is great. If there is one use case that I want to get started with, how do I go about thinking, how do I choose the right workload for the right use case, right? Where can I get started with? What are people using? What are all these SaaS companies using CockroachDB for, right? So there are 4 popular use cases that we see. The first one is customer system of record. This is the most common, right? Where you say, hey, I have tens of terabytes of data, which is my customer data. I need it to be consistent. I need it to be available at all the times because this is very critical. And I also need a SQL experience on top of it. But at the same time, I'm not willing to do manual sharding because this data is growing exponentially as soon as I keep onboarding more and more customers. So customer record system is one of them. We have customers like Fortinet, who has a platform called Fortinet SASE, which is their SaaS-based product offering that uses CockroachDB as their customer system of record database, and Starburst. Anyone who's used Trino here, which is a SQL query language, it's a very popular SQL query language for heterogeneous databases, right? So they have their own managed service offering called Starburst Galaxy that also uses CockroachDB under the hood. So it's essentially like a database for databases, right? Metadata management, a lot of times when you're building companies, you have a lot of system data, you have a lot of billing data, you have several terabytes of log data, etc. That's another use case to use CockroachDB for. We see companies like LaunchDarkly and Rubrik that leverage CockroachDB for metadata management. That's another use case that we see quite popular. Transactional analytics, right? There is a notion that analytics can take how much ever amount of time it's possible and people and users are just going to wait. That's not the case anymore. There are several use cases where you need to take certain decisions based on certain analysis extremely quickly. These are near real-time use cases. You can definitely use CockroachDB there. We have some companies using it. And again, one of the other popular one is identity and access management, where you want to store your authorization and authentication data into CockroachDB at a global scale. We have customers like Ori and OZ leveraging us there, right? I know this is a very scary looking slide. I was thinking twice before putting it, but it's actually very simple, right? It's exactly something that we discussed. This is an actual customer. We've anonymized it. What you see in top of this is the US cluster on the left-hand side, and they have multiple tenants. So they have an architecture where they create a tenant within their SaaS ecosystem for every customer that they onboard. All these tenants are using transactional and metadata services across. If it weren't for CockroachDB, they would end up creating this cluster in every region they were there. What you see in the blue layer is one single logical CockroachDB cluster of 9 nodes spanning across different regions. This is just one single cluster. These are not separate clusters. So you have 3 nodes in US, you have 3 nodes in India, you have 3 nodes in UK, acting as a single logical database. You can read from any node, you can write from any node. Of course, you might have questions about latency and stuff like that. We have a lot of ways and means to kind of optimize for that, and we can give you, CockroachDB is extremely flexible. So you say, I want to prioritize compliance, we can do that. You say, I want to prioritize latency, we can do that. You say, I want to prioritize resilience, you can do that. And there are always trade-offs with that, but this identity access management use case is a very read-heavy use case. You're not going to, the only time you're going to write is when you're onboarding a new customer or adding or changing some of the attributes of the customer, right? And that's why it works really well for them, that they don't have to manage multiple clusters, they don't have to manage multiple databases, one single cluster all across, which speaks to some of the common services as well. If it weren't for CockroachDB, they'll probably doing all these common services separately in some of the separate regions, right? Now, talking about one of our publicly referenceable customer, which is Starburst. So they gave a very interesting talk in Vegas at the AWS reInvent Summit a couple of years back. We started our engagement with them in 2021, where they said, hey, we have this open source product called Trino, which is self-hosted, but we are also building something called Starburst Galaxy, which is going to be our managed service, which can run on any cloud. It's cloud agnostic, and we want a transactional metadata layer to store our terabytes of data on top of that. So their quest for a database started in 2021, and they said, we want to build a centralized product with a distributed architecture. And they wanted 3 clusters, as I showed in this particular slide, across different regions. And they wanted to ensure customers are able to have data even during complete region failures. So their survival goal was, hey, if the US region completely goes down, I should be able to still serve some of my customers when it comes to our operations, right? So they started engaging with us, and they laid out very specific requirements when it came to the database. The first requirement was we need something which is cloud agnostic, because our customers are invariably going to be on any cloud or every cloud. So we want to be freed from those shackles that I can only run on AWS or GCP. So that was one key requirement. They wanted out-of-the-box fault tolerance. They wanted to be able to scale across multiple regions as and when needed. And they also wanted the ability to bring data as close as possible, right? So data compliance is not the only reason why you tend to have multiple clusters in different geographies. Sometimes you also want to serve your customers which are closer to where they are so that their customer experience is amazing. This is what was there on their mind, and they wanted low latency. In 2021, they chose CockroachDB because it kind of sufficed all their needs. And as I said, their survival goal was surviving a complete region failure. So if one of the region went down, which means if the entire 3 nodes in US went down, they still have the majority of the nodes, which is 6 nodes, which are available to serve their traffic. They said, we trust our business to run on CockroachDB. It is storing some of the most critical data for us. And we also know that there is a talented team behind the product, which is always going to be there, right? And this is how their architecture looks like. This is also in public domain. This is the Galaxy architecture, where they have Trino clusters in all 3 regions, and they speak to AWS US West, AWS US East, and AWS Asia South, right? Okay, this is great. Now I do understand the problem CockroachDB solves. I do understand where can I use CockroachDB. I do understand who's using CockroachDB. How do I get started, right? You can consume CockroachDB in multiple ways. The first way to consume CockroachDB is we have a serverless deployment. So anyone who's heard of DynamoDB or used DynamoDB, right? So it works exactly like DynamoDB. There's no concept of infrastructure. You get started. You can tear it down to 0, and all you need to do is you pay by request units that you make to CockroachDB. But if you want something which is more, I would say from a QoS point of view, which is more dedicated, which is something that you want specific only for you because you are expecting that, hey, I want specificity about how I'm going to use CockroachDB, you can also deploy CockroachDB as a managed service, which is called CockroachDB Dedicated, where we commit that this hardware is only going to be used by your platform, and you get all the advanced security features as well. But if you say, hey, I'm a pro at running databases, and I would like to go back to the old ways of running databases, just give me the binary, and I want to run it on EC2 machines, or even in my private cloud, you can deploy CockroachDB as a self-hosted manner as well, right? So in that sense, it's extremely flexible. CockroachDB can run wherever you want to run and whatever platform you want to run on, right? So there are 1 or 2 things which can happen after this talk. We all go break for lunch and forget about this session. Or you can take action and spin up a CockroachDB cluster by scanning this QR code. You'll get started in 5 minutes. You'll have your own CockroachDB cluster running. You can point your application towards it. You can test it out. You can see what kind of experience it's giving you. It's got its own inbuilt query optimizer. It's got a lot of brilliant features, so you might definitely want to test it out, and it doesn't cost anything. And we've got our booth at S6, so you can visit us. We are going to be there for the next couple of days. That's me on LinkedIn. And just before I was going on the stage, our HR team also pinged to share that we are hiring. So just passing on their message that we are hiring, right? Thank you. Thank you for your time.
Any questions?
Yes, we have some time, so we can take a few questions if there are any questions. People usually don't have questions only in 2 scenarios, when everything was clear or nothing was clear. So I don't know which one is that. But if there are any questions, we can take questions, yeah. Okay. So the question is, how many reads and writes can CockroachDB handle in a single second? And I'll give you the answer that our engineers typically give us is, it depends. But of course, CockroachDB is highly scalable, so we have benchmarked at millions of operations per second. There are some factors to consider. It depends on what's the read-write ratio. So if you're doing just pointed queries, you can scale much higher numbers. But if you're doing complex queries, then the TPS would be low. But that's exactly the problem that we are solving, that very high transactional workloads typically have a problem of TPS. When we are speaking to architects who are designing extreme solutions for large banks and large organizations, they say, my requirement is for 15,000 TPS, 20,000 TPS, 50,000 TPS. For every TPS, there is a request which is going on. So how do we make that system extremely scalable? And this is what I think this is where monolithic databases kind of really come short, because they are only dependent on that single master writer to do all the transactional heavy stuff, right? Yeah.
When do you typically see companies actually migrating into CockroachDB, like in your customer base?
Yeah, so the question is, what are the triggers to see when to use something like CockroachDB? Interestingly, we've seen the whole spectrum. So we have seen companies like less than 5 employees who started building their entire database on CockroachDB, because this was a SaaS company who was dead sure they're going to have operations in US, India, Australia, and other regions. So they were like, we don't want to solve for this problem and move from PostgreSQL after 2 years or after 18 months. We want to solve for this now. And that's where our serverless offering comes very handy, that hey, if you are going to do some integration testing, or if you are going to just start small, you don't need to invest a lot into infrastructure, and you can get started small. And we've seen companies with more than 5,000, 50,000 employees also using it. It just depends whether you want to start as a greenfield project, which is easier to start, versus you want to take this decision to move to something modern and distributed when you hit the scale problem. I think it's more of a strategic decision internal to an org. But we see both cases.
I have one question.
Yeah.
Related to the cost.
Yes.
So just example of if I want to store 500 gigs
Yes.
in CockroachDB, what is the monthly cost it is going to be?
So we have our pricing calculator online. So you can create an account and you can say that, hey, I want 500 gigs of data. Okay. I want these many IOPS. This is my AWS region, like let's say Mumbai, and then it will show you what's the cost. However, I do want to share one insight, because we get this a lot.
Yeah.
The cost is not going to be vis-a-vis as a monolithic database, only because of the amount of data redundancy that you need to have. When it comes to monolithic databases, all you're doing is a master and a replica setup, right? So 500 gigs is getting replicated to another instance of 500 gigs. With CockroachDB, we store the data 3 times. So there is a slight overhead that you need to give in from an infrastructure standpoint, but it comes with benefits like ability to survive failures, which highly outnumbers the benefits that you get, from CockroachDB.
Okay, I'm just giving one simple example for that. I have a RDS Postgres.
Yep.
Monthly cost is 4K.
Mm-hmm.
So if I'm moving to the CockroachDB, is there any cost benefit? Single, I think you take that any of the zone. Just suppose that US East zone.
So it's not just with CockroachDB. I wouldn't advise to move to any distributed database for cost savings only. If you're just talking about tangible cost to tangible cost.
Okay.
But if you add up, it's like an iceberg, right?
Okay.
The tip of the iceberg is the cost that you see on AWS console and CockroachDB console.
Okay.
Under the hood, there are a lot of things which go as the manual toil and the manual sharding you might have to do at scale, etc. Right?
Yeah.
Plus the amount of planned downtime that you are taking. So if you add up all that cost, this equation would become very lucrative. But if you're just going to add per hour pricing, any distributed SQL database needs a slightly additional overhead because of the way they are architected.
Makes sense.
Right.
Thank you.
Oh, thank you. Can you please talk about migration? Like how easy is it to migrate to CockroachDB if you are using RDS Postgres? And because you said that it is the same API.
Correct.
So how does that work? And
correct. So the short answer is extremely easy. If you're familiar with services like AWS DMS, just load the data into DMS. DMS could do all the work for you. That's one way to migrate. We have built some very cool tools internally. We call them MOLT, M-O-L-T, which is migrating off legacy things. So you can use those tools. They will stream the data from the old cluster to the new cluster. So you can do live migrations, you can do backup and restore migrations, you can do a bunch of migrations. Our documentation is top notch, but if you're coming from RDS Postgres, it should be a breeze. Right? Yeah.
I understand that you have a tool where I can migrate my existing data. Does this tool also support, let's say, migrating my indexes, foreign keys, constraints, etc.?
I'm not familiar with this question, but we do have architects at our booth today, so we can discuss that.
All right. Yeah, that's my question. My question is basically on the data migration part. Do you have any tools? Nice. Great. Thank you.
Yep. All right, so thank you for all that questions.